it. So thank you so much for opening this video just with the purpose of knowing how the Quicksort works. So without any delay, let's first see how the Quicksort can work in a visual form. Okay, if this does not make sense to you, we can use the image and explain how the Quicksort works. Actually, what is sorting? Sorting is the way of arranging elements in either ascending or descending order, or yes, actually the elements of an array. So in the Quicksort we have many ways of arranging the or many algorithms to follow for arranging elements in an array. So here we're going to see on the technique called the quicksorting. Quicksorting, we actually on the first step of quicksorting, we do actually choose the element to be one element of the array to be to be the pivot. Actually, the pivot is a reference of other elements, or a reference where we compare other elements to that element and decide where we are going to keep them. So the first element is choosing a pivot. You can choose a pivot any number that you want. That number can be either the first element or the element in the middle, or even the element on the last position. So for me, I always prefer using the element on the last position. That's my routine approach. And then after choosing the pivot, you are going to compare all the numbers, all the rest numbers to the pivot, and the numbers which are less than the pivot will be kept in on the left, and the numbers which are greater than the pivot will be kept on the right. When you do this, when you just need to sort in ascending order. So for them to be kept on the left or to be kept on the right, you understand that we are going to define other arrays on the left side and on the right side. After doing that, we will just do the same to the newborn arrays, and we will go to choose the pivot. For example, here on the left side, we choose the pivot also to be the last number, and compare the rest of the elements in the right side element to it. The left, of course, will be on the elements on the left also, because of course will be the numbers less than the pivot, and the numbers greater than the pivot will be on the right. If there are numbers greater than the pivot, of course the right side will be empty. That can be possible also, and that steps also will be done on the right side array. So we will choose the pivot, and we compare the rest of the numbers in the right side array with the pivot. The smaller number will be on the left, and the larger number will be on the right. So if we have an array, for example, of even 1,000 elements, we continue that 100 times till the whole array is sorted out. After doing all that, we just add up all the arrays from the left with the arrays from the right, but we just remember that we have to include the pivot element. So we concatenate, actually call it concatenating the elements in the right, and the elements in the right and the elements in the left side of the array, the left side arrays, and plus the pivot elements. So we will just come back to have the real or the original sized array, but which will be the sorted one. So let's see how we can implement that in JavaScript codes, and see how we can do this in a very simple way. So we just need to create a new file which will just do all where we will write our codes. Let's call that file quicksort, and first define the function of sorting, which function will be, let's call it quicksort function, and we will pass one argument. That argument will be the array to be sorted. Of course, we saw that the first step in the quicksort algorithm is defining the pivot. So the pivot in our case, or in our approach, will be the last element. So array last element is the element on the last position. The last position is length minus 1. Yes. Then we will also define the left array, but for this moment this left array is empty, and also define the right array, which is also empty. for the moment, because we have not yet started comparing the elements and keeping them where they must be kept. So the next step is just walking or transversing through the array and create the position. Actually, transversing includes creating the position variable, which will initially be the position 0 or position 1, which is numbered by 0, and I if I is still less than the length of the array, so we will have to incrementing also, or continuing, if we can say that too. So if the array or the okay, if the element on the current position is less than the pivot, yes, is less than the pivot, so we can do what, we can keep it in the left array. So we will use the predefined function called push, and we pass the element on the current position. Yes, that's it. And if the following condition is not true, it means if this condition is not true, the other option left is that this element on the current position will be greater than the pivot. So we will do it like this. We will just keep it in the right array. So right push, yes, array element, yes, the element on the current position, yes, it will be kept in the left. Since this is in the loop, it will be done iteratively till this condition is fulfilled, and the iteration will be dropped out. So we will have to return the whole original sized array, which will be the concatenation, or which will be the combination of the elements on the left side arrays plus the pivot elements that we've chosen throughout the implementation of the algorithm, even plus the elements on the right side arrays that we created throughout the implementation, of course. So now we need to return the array as one unit. So we have to check first if the length if array.length is less than 2, that means if it is equal to 1, then we are good to go. We are now able to return. Yes, we are now able to return the array. So since we've just defined the array, but this time the array does not have any value, or does not have any elements, or is not initialized, so we have to initialize it out of the function. And initializing includes just putting their random numbers. For now, we can put their random numbers. Yes, 0, 89, 67, 56, 43, 10, and so on and so forth. Then we will need to print out if all these codes are working well, but we don't print out the result, we won't see how the codes was implemented. So we need to print out the quicksort result where we've passed the array, of course. Yes, this array is passed in this function. I think you're seeing it. So we have to save and check if our code is really working, or it is running properly, if it is giving the expected results. Before running, you can see that the expected results can be of course -6. Yes, let's see, -6. Then we go with negative, because we are in ascending order, -5, then 0, then let's see, 9 can be the next value, then 10, then say 43. Yes, after 43 we could have 56, then 67, then 89. That's how it could be. That's how the answer could be. The answer must be this one. So let's see how, run this node quicksort dot js, run the file that we created, of course. then run and see. So I think you are seeing that we are having the elements, yes, as we expected them to be, because it is in ascending order. We are just sorting in ascending order, coming from the smallest value to the largest value. So if you want to reverse the sorting process, well, of course, if you're saying reversing means in decreasing order or in descending order, we can only change this symbol to greater than. So let's see. So now you can see that we are starting with the largest value. Actually, in the sorting, I saw that here in the comment, I forgot to put 90. So we start with the largest value and end up with the smallest value. I think this really works well. Thank you so much for joining me today and following all my tutorials. Keep hacking, you guys. Thank you so much.